Well, what do you think about this first equation?
3.
Oh, why 3? Why are you saying that?
7 plus 3 equals 10.
Okay, that's the number that makes it true, right? You remember that? Didn't you do that in 3rd grade? Your 3rd grade teacher gave you this worksheet with the empty box, and you put the number in, and then your teacher was like, my 8-year-olds are doing algebra. And you were solving equations. That's all there is to it. Now this one, we have to think a little bit more about, don't we? What number?
Negative 13.
Negative 13?
Yeah.
I think that might be right. If we put a negative 13 there, negative 7 subtract negative 13. Does that work? That works, doesn't it? That was a little bit of a thinker there, wasn't it? Okay, you have to get the addition, so we had to subtract a negative number. I think sometimes when we look at equations like this, I think sometimes you guys think that the number here that x is a negative because there's a subtraction symbol in front of it, but that doesn't mean that. This number is independent. It can be a positive number or a negative number. It has nothing to do with this symbol out here. So it might say 6 subtract 4, or it might say 6 subtract negative 4. We just don't know. So we're going to start solving equations today. And, you know, I bet you can all just look at it and probably come up with a number that makes it true. Can you tell me the root of this equation? 15? So is 15 the number that makes it true? Okay. So that's not what we're learning today. All right? I understand you guys can look at these, you can get the answer, you can tell me the answer. Today we are learning how to show our work so that when these problems get more difficult, you can still make it happen. Okay? So this is what you have to be able to do today. First of all, we're going to write down the equation, and then we're going to think about, okay, this is x subtract 3. By the way, isn't that 1x? Okay, so 1x subtract 3 equals 12. I don't want it to say 1x subtract 3 equals 12. I just want it to say x equals some number. Okay, so I don't want that subtract 3 right there. So you guys did this last year. What do we need to do to both sides of the equal sign? Now, if I do it on this side of the equal sign, then what about over here? Do I have to do it on that side?
Yeah.
What happens if I don't do it on that side?
You're wrong.
It wouldn't be equal anymore, would it? Okay. So, what do these add up to? 0. So I'm going to cross them out. And now I have a new equation. I have x, 1x if you like, equals, do I need to put down 0?
No.
Okay, just equals 15, doesn't it? Now I could have shown my work a little differently. You can put the plus 3 on that same line like this, but you see how it's kind of hard. It's kind of hard to jam it in there, isn't it? And so usually we write it underneath. And then this big line, I want to make it clear. That's like when you go 47 plus 8 and you put that line, that addition line right there. That's what this line is right here. So this is what we're going to show on our paper. I understand you don't need to do all of that work in order to tell what the answer is right now, but you're going to have to by, I don't know, Thursday, Friday. They're going to get complicated and you're not going to be able to tell what the answer is without knowing what you're doing. So what's the deal with this add 3 to both sides? Why do we have to add 3 to both sides? Why can't I just add 3 to one side? So let's start with the true equation. That true? Okay. If I subtract a 2 from this side of the equal sign, is it true anymore? No. But yeah, but if we subtract 2 from that side as well, is it still true? It is. Okay, and that's basically the idea. And by the way, what if I were to add 2 to both sides? It would still work, wouldn't it? Okay. Think of an equation. Think of that equal sign like a balance scale. Have you guys seen these old-fashioned balance scales before? They have a little plate here and a little plate here. They have a balance right there in the center. And on one side we have something like 10, and on the other side we have something like 12 subtract 2. Are they equal? So hold your hands up like this, right? They're equal. They're balanced, right? They're still balanced. Now, if I come over here and I add 4, what's going to happen? Yeah, exactly. It's just not balanced anymore. It's not equal anymore. So what do I do over here?
Add 4.
Add 4. Now what happens? Are you back to balance? Okay. This is called the addition property of equality, and there's a subtraction property of equality. And all they say is, as long as you add the same amount to both sides of the equal sign, or subtract the same amount, it's still equal. And we use that to solve equations. Now, the last one I showed you, you could just look at it, you knew the answer right away. But it doesn't have to get much more difficult. And you know what? I don't think you guys can just look at that and tell me the answer. Just snap your finger fast, can you? No. You need to write it down, and then you need to think about, all right, I don't want x plus 1/4 equals something. I just want it to say x equals the answer, right? So, I don't want that 1/4 right there. What could I do to get rid of it? Subtract 1/4. Okay. So if I subtract 1/4 from that side, though, what do I have to do over here? I heard someone say subtract 2/8. Why 2/8?
Because that's the 2/8 and 1/4 of it.
Yeah, there you go.
The common denominator.
They're common denominator. Negative 2/8 is the same as negative 1/4, and there you go. So I put my big add subtract line underneath. What do I do with these two? Okay. Now they add up to 0. Do I need to write down x plus 0? No, I don't need to write the plus 0. And on the other side, negative 3 subtract 2.
-5.
Okay. Now I know you guys look at this like it's the answer, like it's an answer. It's really an equation. It's an equation. Now it's an awful simple one. Can we tell what the solution is? What number needs to go right here to make this thing true? Okay. So we often think of it like it's the answer, but it is in fact an equation. And these two equations are what we call equivalent. They're not the same equation, but does the same number make them true? Cooper shook his head yes. The same number makes them true. So if the same number makes them true, we call them equivalent equations. And that's kind of what we're doing, is we're making an equation that's equivalent, but we can see the answer a little easier. So let me show you something here. See those two equations? They don't look like they're even kind of the same. One's got an A, one's got a Y, right? Put your mask on. But do they have something in common? Let's solve this one. What do I need to do to both sides? Now you need to show subtract 2. Don't just put a 2 down. Big line underneath. These add up to what?
0.
And what does our new equation say?
A equals -5.
Okay. A equals 5. Over here, what do I need to do to both sides?
Plus 5.
Add 5. Add 5. Big thing. These add up to 0. What's the new equation say?
Y equals y.
Okay. So what do these two original equations have in common?
Equals
Equal 5.
They're equivalent by.
They're equivalent. Yeah, they're equivalent. They have the same root. Isn't that right? The same number makes them true, so we call them equivalent. Even though this is an A, this is a Y, it doesn't matter what variable we use. The same number makes them true, so we call them equivalent equations. Okay. Okay. I'm going to show you one. This is Dallin's favorite because it has fractions in it. Let me just tell you something about fraction. Let's review a little bit. Adding and subtracting mixed numbers, is that really a big deal? No. What about timesing and dividing? That's okay. Now with equations, you almost always end up having to multiply or divide at some point. So mixed numbers just don't usually work very well, okay? So when I see an equation like this, if it has fractions in it, I write everything as a fraction. I don't write mixed numbers. So I would write it down this way. Let's see. 3 times 2 is 6, plus 1, that's 7 over 3 equals 2 over 9. So I would write them down this way. Now, it doesn't really matter in this particular case, but later on, you're going to have to multiply or divide, so we're going to do it this way. So this is what we would write down. And then what do I need to do to both sides of the equation?
Subtract 7 over 3.
Okay. Subtract 7 over 3. Subtract 21 over 9. What?
Yep.
Yep. So I have space here. So I just took this and said, well, I want the denominator to be 9, so I multiplied by 3. And then on the top, I multiplied by 3, and that gave me thing. Now, I'm subtracting. Make sure you say subtract. What do these add up to?
0.
Okay. So on this side of the equal sign, I have 1 times k. We don't often write the 1, but it's a good idea to know it's there. And then 2 subtract 21. Negative or positive? Okay. Now, how do we know that's the correct answer? Can we check it?
Yeah.
Yeah, we can check it.
Plug it in.
You could even use a calculator to check it. You can type in negative 19 over 9. Here, negative 19 fraction 9 plus 7 over 3. So plus 7 fraction 3. And what should it equal? 2/9, right? It should be 2/9, does it? To work? Will any other number work?
No.
No, that's it. That's the only one that'll work. All right? Okay, so get out your paper where you're going to do set 23. And I just want you to write down this equation. I want you to show me all the work and the answer the way I've taught you to do it. It should take 10 seconds. Don't just write down the answer. Write down the original equation. Show me what you do to both sides. Put the big add subtract line underneath. Write the new equation. Pretty easy?
Yeah.
Okay, so I walked around and looked at some of you, but did you write this down just like that? Did you put a subtract 5 and then a subtract 5?
Yes.
Did you make sure they're on each one on each side of the equal sign? Don't do the same thing to one side of the equal sign twice. Do you have this big add subtract line here?
Yes.
That's kind of important. Did you cross these two out since they add up to 0?
Yes.
Okay. And now we have a new equation that's equivalent to the first one. We have x equals 12. Right? What number makes this bottom equation true? 12. What number is going to make the top equation true? 12. That's it. That's all there is to today. Now, are you a little bugged that I'm making you show all this work when you can see the answer? Who's a little bugged at me right now? It's okay. You can raise your hand. It's fine. I understand. If I didn't understand what's going on, I would be bugged too. So So let me just show you something. By the end of next week, this is what you're going to be doing.
That's easy. That's so easy.
Good. Okay. And you guys know how to use the distributive property. You even know how to use the distributive property here. We subtract 6x and we subtract 2. You know how to add like terms. 21 and 24 can go together. That's just 25. And over here, the 4 and the negative 2 can go together and give us a 2. And this is kind of what we're talking about today. If I don't want something on one side like this, I need to, I don't know, I could add 6 times x to both sides so that these add up to 0. So this is negative 18x plus 25 equals 2. Now this is really where we are today. Now I'm making them easier. I don't the coefficient's always a 1 right here, but it's just, this is what we're doing today. We're subtracting 25 from both sides. So these add up to 0. That right there is what we're doing. And then we're going to do another step. We're going to still have to keep going. Positive 23 over 18. Now, can I look at this original equation and tell what the answer is? Or do I need to show work and solve it? I need to do this to get the correct answer, and so do you. And you see, if we're not showing our work on each step, what's going to happen? You can't do it. You just flat out can't do it. So I'm not just making you do this to be mean or anything like that. Although that is the fun part. I am, there's a reason, there's a method to my madness, and it's going to make your life better, okay, down the road. Okay, let's do another one. Let's do this one right here. Is it bugging you that I've got the variable on the right-hand side of the equal sign? Does that matter? Doesn't make any difference, does it? Do the same thing. Write it down. Show me what you do to both sides. Big add subtract line underneath. Cancel things out. Write the new equation. Come on. Today, man. Could have been done by now. So you wrote it down, right? Underneath here you put subtract 27. Over here you put subtract 27. Did you put a big line underneath? Did you cross these two out? This is negative 65. Negative 65. Sorry, I added up out loud. Equals k. Now there's no difference between that and k equals negative 65. And we're not going to worry about which side of the equal sign the variable's on. Doesn't matter. Left hand, right hand, that makes no difference whatsoever. You got it? Okay. Now here's one you probably can't just look at and tell me the answer. Although maybe it's not too bad. Write it down. Show me the work. Do it all correctly. Okay, so you wrote it down. You subtracted 1/2 from this side of the equation, and on this side, you subtracted 1/2. Is that correct?
You gotta add.
Yeah, you gotta add.
Why?
Oh, because it's,
Why can't I subtract that from both sides?
Because that
it's
one
gotta
is
be
true.
the opposite and on the number line.
Well,
And 1/2
would it still be, would the equation still be true
No.
if I subtracted 1/2 from both sides?
Well, technically, yes.
Okay, so let's talk about this. This is negative 2/2. And this would be negative 1/8. And I just want to make something clear. We didn't break a rule here. We subtracted the same amount from both sides of the equal sign. This new equation down here is equivalent. It has the same solution. But can we see the solution? No. Was subtracting 1/2 from both sides, was it helpful? No, it didn't help. We didn't break a rule, but it didn't help. Now look what happens when we add 1/2 to both sides. Now what happens right here? Yeah, they cancel out, and we just end up with something simpler. X equals 7/8. So this is a problem sometimes when we're solving equations. You can do something that's not breaking a rule, but still not helpful. So you've got to watch. You've got to make sure that these are going to actually cancel out. And there's our answer. That's the number that makes it true. There you go. Okay? So now let's look at set 23 for a minute. Number 1. What does solve an equation mean? When you're told to solve an equation, what is that talking about? What is it telling you to do?
Find the simple form.
Find its simplest form. What was that?
Simplify.
Simplify it.
Make any numbers.
Make it even. Well, it's already even because it's equal. Simplifying it, how does that help us?
It makes it simpler.
What are you really doing? What's that? You're finding the number that makes it true. Number or numbers. You're finding the value that makes it true. We find the roots. The root or the roots. And that's the number that makes it true. So that's all we're doing when we're solving an equation, is finding the number that makes it true. Number 2. What are equivalent equations?
Equations that take the same number to
Good. Equations that have the same, can we say equations that have the same root? Or equations that the same number makes them true? It's probably easiest to say they have the same root. They have the same solution. Now I keep saying root or roots or solution or solutions. Your equations, the ones you're going to be given, they will have one solution. Only one value can possibly make them true. And we can tell because x is exponent. What's the exponent right here on x? If nothing's written there, what is it? It's a 1. When that's the case, that means there is one solution, one number that will make it true, generally. It's possible that anything will make it true or nothing will make it true, but for right now, we're just going to say one number, one root. Okay. What's the sum of the angles of any, of the 3 angles of any triangle? Okay, make sure you put 180 degrees. Put that little degree symbol up there for me. Number 4, super simple one, don't make it hard. You will have time to get this done before the bell rings. I expect it done before the bell rings. Yo!
What should we do with set 22?
Didn't we hand that in?
No, you said we would talk about it.
Do you have some questions? Okay, give me a score, put it in the box. Good job, guys.